Okay, this section you're going to learn about Pascal's triangle, which is really cool. And it's got a ton of applications that you can use. In fact, when I was reading the textbook to review, one of the applications, when we play Plinko for prom, where the game where they put the little like poker chip at the top and it can go down the side or the middle and land somewhere. Once you see Pascal's triangle, the higher the number on the triangle, the better odds it is of going in that direction. So, it's just one application of Pascal's triangle, but if you kind of picture that as a Plinko game. But the application that we're going to talk about specifically in this section is how to use Pascal's triangle for binomial expansion. Binomial just means two terms in a polynomial. And we can do something like this squared pretty easily. But when you get to something like this, the only way right now that we know how to do it is to take this squared times itself 3 times and then having to FOIL over and over and over again until you get something really huge, and then having to combine all your like terms. Well, Pascal's triangle gives us a shortcut for how to calculate this. And the thing that you need to remember is really how to construct the Pascal's triangle. And it's really easy once you see the pattern. You're going to start with the top of the triangle is the number 1. The next row is also going to be 1. And as you move down the triangle, the outside number on both sides of the row will always be 1. To find the inside, you're going to add these two numbers together. So my outside will always be 1. Okay, so my next row, my outside's 1. I add these two together. I add these two together. My outside's 1. Next row is 1. I add these two together. Add these two together. And I'm starting to build this triangle. 1, 5, 10, 10, 5, 1. Okay, and it goes on forever. Okay, so we call this row the 0 row, even though it's the first row. We call it the 0 row. If I'm dealing with 2x plus 3, okay, 2x plus 3 to the 0 is 1. Okay, so this is representing my row. 2x plus 3 to the first is just 2x plus 3. So I could say it's 2x to the first power, 3 to the first power. Okay, so this is where it kind of gets fun, is when we get into the next. So row 0, row 1, row 2. So this is going to help me figure out 2x plus 3 squared. Okay, so the way the pattern works, this is going to be my first term, and this is my second. 2x is first, 3 is second. Okay, so my first, I'm going to say it's 2x to the first power, 3 to the 0 power. Is that what I want? I got to do this right. No. 2x squared, 3 to the 0 is going to be the first term. I'm going to start with the highest exponent there is, and that's going to be assigned to the first term. And the lowest exponent there is will be assigned to the second. And I'm going to increase the exponents for the first term as I go right, and decrease the exponents for the first term, increase the exponents for the second. You'll understand what I mean here. So my next term is 2 is my coefficient, plus 2. And now I've got 2x I'm going to raise to the first term, or first power. 3 I'm going to raise to the first power. So I decrease this exponent and increase that one. And then I go on with this next pattern. It's going to be 1 is my coefficient, 2x to the 0 power, 3 to the second power. I'm decreasing the exponent of my first term, increasing the exponent of my second, and putting the number in Pascal's triangle as my coefficient. So when I simplify this, this is 4x squared 2 times 6 is plus 6x, and plus 9, which we know this is true with this one. Square the first term, square the second, and then the product of the 2 times 2, which would give me, actually, should be 12. Not explaining this very well. 2 times 2 times 3 is 12. So let's do the third, and it'll start making more sense the more we do these. I'm not lying.
How do you know, this crap stuff?
Okay, so we're on, this is 2x plus 3 squared. This one's going to be 2x plus 3 cubed. Okay, so I'll go slower. Start with the coefficient of 1. Okay, I'm going to write both of my terms, and I'm going to start with the greatest exponent first, here, the smallest exponent first, there. And I'm just going to work my way to the next one. I have 3. I'm going to write both of my terms. This is going to be 1 less. This is going to be 1 more. I'm going to do my next one. 3 again. This is going to be 1 less. This is going to be 1 more. And then 1. I don't know if I can go over anymore. 2x to the 0. 3 cubed.
So will you ever get a negative exponent?
Nope. And what you'll notice is the sum of all the exponents are always equal to the exponent of the binomial.
Yeah, so you keep taking one and then you just
Okay, so now I can simplify this. 2x cubed is 8x cubed. 3 to the 0 is 1. So there's my first term. This is 2x squared, so that's 4x squared times 9. Right? 2x squared is 4x squared times 3 times 3 times 9. Then I have 9 times 3 is 27, times 2 is 54x. Then I have 1 times 1 times, or plus 27.
So what about that one that we got at the beginning? Like 3 to the 0?
That's 1. 1 times 2x cubed times 1
Yeah.
is 8x cubed.
Yeah. I think it was 1, but I was thinking about 9.
Okay, so let's just check it. We know we start with 4x squared plus 12x plus 9. This is 2x plus 3 squared, right? And if I multiply that times 2x plus 3, 4x squared times 2x is 8x cubed. 4x squared times 3 is 12x squared. 12x times 2x is 24x squared. 12x times 3 is 36x. 9 times 2x is 18x. 3 times 9 is 27. 8x cubed, 12x squared and 24x squared, 36x squared. 36x and 18x, 54x, 27. Okay, it may have taken me about the same time to do it this way and this way for the cube, but as my exponent gets bigger and bigger and bigger, this pattern is going to be a lot faster. You want to take a shot at the fourth? You guys want to try it before I do it? One, two, one. There's supposed to be a 1 here. So this one, this row will be to the fourth.
Okay.
Everybody have a shot at tackling it? Are you about through, Sam?
I'm confused. I think I'm wrong. Yes, I believe it's wrong.
Okay, so let's see if I can do it. All right, so my first coefficient is 1. Then I'm just going to write 2x and 3. It's going to be 4 and 0. Next coefficient is 4, 2x cubed, 3 to the 1. Then 6, 2x squared, 3 squared. 4, 2x, 3 cubed. 1, 2x to the 0. Let's do 1 there. 3 to the 4th. So this is 16 times 3, right? 48x to the 4th.
Shouldn't it be 16 times 1?
Oh, yeah. Thank you. Yeah. Would help if I look at my exponents. 16x to the 4th. Okay. Plus 2 cubed is 8 times 12. 96. 4 times 18, what is that, 52? No. 72. 72x squared. 24 times 3, yep. Okay, plus 3 cubed is 27 times 8. 216. Plus 3 to the 4th is 81.
And you just go down from 4, or like you just keep going? down
4,
the next
3,
one?
2, 1.
Okay.
And I go up 0, 1, 2, 3, 4.
How did you get the 72x squared?
Okay, did I do something wrong?
I got 216.
Okay, so 4, oh, because this is 9, not 3, times 54. Yes. I told you I'd try and do it. There is no web work that'll ask a question on this, but you do have a CK12 assignment, and I will have a question on the test. Okay, so the biggest thing is that you're comfortable recreating the triangle. Just start with 1, and then the next row is 1. Make sure that the bookends of every row are always 1. And then the middle just comes from the sum of these two. And the sum of these two, 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 and so on. And then understand that those numbers are the coefficients. You'll start with the first term with the highest exponent that there is in this whole series. The second term with the lowest, which would be 0, and then you gradually increase on the first term, decrease on the first term, increase on the second. it's kind of fun. And it's pretty cool that there's something that exists like this that makes, I mean, imagine doing 2x plus 3 to the 21st. Yeah, it's still going to take you time to do Pascal's all the way across, but it's a lot less time than it would be to FOIL all the way across. So it's kind of a neat thing. And there's lots of other applications that Pascal's triangle has in probability, combinations, permutations, that kind of stuff. But right now we're just going to focus on square or binomial to the nth term.